In continuation of the HiTek Studio software tutorial videos, today we want to get familiar with HMI internal memory. In the Component tab, we're going to bring in a numeric input and a numeric display, and we'll read a value and write a value. Let's continue with this video and do this together. In the previous session's videos, we learned how to create a project in HiTek Studio software, which is specifically for HiTek brand HMIs, and we went over each of the tabs in this software to see what tools are inside and how to use them. Today, we want to talk about the internal memory of this HMI, and in the Component tab, we're going to learn about numeric inputs and numeric displays. If we want to enter a number into the HMI or read a number from the PLC inverter or any other device we've connected to, we need to use the numeric value. Displays and numeric value inputs. What are the differences between them? As their names suggest, numeric value displays are only for reading, meaning they're used just to read a value. Numeric value inputs, on the other hand, are used both for writing, that is, entering a value, and for reading a value. So, if we want to enter a value and send it to the PLC, inverter, or whatever device we're communicating with, we need to use numeric value inputs. And if we want to read a value, we should use numeric value displays. So, here I'm going to bring in a numeric value input, and a window will open up for me. Here, in the operation attribute, we need to specify whether this input we've added is a numeric input, a numeric display, a character display, or a character input. In this case, we'll set it as a numeric input. We need to assign an address to every element we add in the HMI. This address can be from the internal memory of the HMI itself, or it can be from the memory of a device we've connected to, like a PLC. So, we can also assign a PLC address to this numeric input element. Here, we want to use the HMI's own memory, so we set the device to local. Local register means we're going to use the HMI's own registers, and we set the address type to LW, which means the address type is LW, an integer type, and the address is 0. So, I'm assigning LW0 to this numeric input. In the tab for this numeric input, there's a tab called Number Format. In this Number Format section, you can specify your data type here. What type is the number you're going to enter? Is it in signed, BCD, hexadecimal, binary, or real, floating point numbers? Here I'll just go with the default, which is 16-bit and signed. Okay, now it asks how many digits your number has. I'll just set it to 4 digits. In this section, Input Lower Limit and Input Upper Limit, you can set the minimum and maximum values for your number. For example, I'll set the lower limit to 10 and the upper limit to 1000. That means if you want to assign a value to this numeric input, you can't enter anything less than 10 or more than 100. Okay, I'll confirm this, and you can see that a numeric input value has been created for me. Now, I want to run this as an offline simulation to do an offline simulation. I don't want to upload the program to the HMI. I want to test it right here on my laptop screen. For offline simulation, you can use this toolbar at the bottom and select the offline simulation option, or you can go to the Tools tab and choose Offline Simulation from there. I'll click on the Offline Simulation option, hit OK, and wait for the page I designed to open up for me. Alright, I'll enter a number here, for example, 20. You can see that my number 20 is saved at address LW0. So, to enter a number in the HMI, we need to use these numeric input tools and assign an address to them. For this numeric input value, we set a lower limit and an upper limit. The lower limit is set to 10 and the upper limit to 1000. If I enter a number below 10, for example 8, you'll see that it gives me an error and says your number is below 10, below the range you defined. If I enter the number 12, you'll see that it accepts 12. Now, for the upper limit, for example, if I enter 1001, you'll see that it gives me an error again and says your number is above the range you defined. Your upper limit is 1000 and your lower limit is 10. Okay, so I'll enter the same number, 300 for example, and confirm it. You can see that the number is stored at address 0 in the variable. Now, I'll click on it again and set the operation attributes to numeric display. If you set it to numeric display, the field you entered here and set to display can now only read the value of something. You can no longer enter numbers into it. I'll click OK and run the offline simulation again. By clicking on this, you can see that my keyboard doesn't pop up when I want to enter a value. Why? Because this is a numeric display type. It can only show the value of a number. So, we've learned that if we go to the Component tab and want to use numeric, if we select numeric value display, we can only read the numeric value. But if we select numeric value input, we can both read and write the value. I click on it, and here we have different options. Font, you can change the font of this numeric value. For example, I set its size to 25, and you can see the size got bigger. I set its font to Real, and I make it bold. You can see that the size, dimensions, and style of my font change. You can also change the graphic of this numeric input. You can either add your own custom graphic from your system, design it yourself, or you can use one from the HMI library itself. For example, I select this graphic and click OK, and you can see that the appearance of my numeric input has changed. So, you can also change the look and style of this numeric input. Here's a practical example. Look, here we have an option. We set this to numeric input again. When we set it to numeric input, a read and write option appears here. When we check this box, it gives us a read address here and a write address. What does that mean? It means you can use this numeric input to read a value from, for example, word address 0 and write a value to, say, word address 1. That means I read the value in the 0 column and write it in the 1 column. I write it, alright. I confirm it, then I add another numeric input value. This time, I set the address to word 1 and make it an input type. If I set it to display, it can only show the value and can't enter a value. I click OK and place it next to word 0. I add a label to both so I know which one is word 0 and which one is word 1. First, I place a label that says word 0 directly underneath this item to clearly indicate its association. After that, I take one of the existing labels from above, make a copy of it, and carefully position this duplicate label right next to the numeric input field. Finally, I update the text on this new label so that it now reads word 1, ensuring each label is clearly identified. So, the idea is that whatever value I enter in word 0 should appear in word 1. I start the offline simulation, either from this toolbar or from the Tools tab. The option is Offline Simulation. Offline simulation is for when you currently don't have access to the HMI and you want to test the HMI program. In this environment, you can test the program you've written. So, for example, I enter the number 25. You can see that whatever value I enter in word 0 gets entered into word 1. Here, I perform a read, and its write happens in word 1. So, in this video, we learned that if we want to read a value or write a value, we need to use the Component tab and do this with numeric value displays or inputs. The difference between these two is that numeric value displays are only for reading a value, while numeric value inputs are for both entering, writing, a value and reading a value. Here's another example. Let's say I want whatever value I enter into one memory location to be transferred to the next address. That means if I enter a value in word 0, it should appear in word 1. If I enter a value in word 1, it should appear in word 2. If I enter a value in word 2, it should appear in word 3. Basically, I'm copying from one to the next. First, I paste it, and then I paste it again, just as before. After that, right here next to this one, I copy it again to make sure everything is in place. Now, this address should be labeled as word 2, and over here, in this spot, it should be word 3. This way, each address is clearly assigned to its correct word. So, I want to assign a value to word 0 so that it goes into word 1. I want to assign a value to word 1 so that it gets written to word 2. And whenever I assign a value to word 2, it should be written and saved at the address of word 3. Okay, now I'll go to the initial input, name Eric input. For the read value, I set its read address to word 0, and it's supposed to be written into word 1, meaning at this address. I click OK. Now, for word 1, it should read from word 1 and write into word 2, which is the next one. I click OK. Now here, it should read from word 2 and save it in the next address, which is word 3. And for the last one, it should only perform the read operation from word 3. Okay, I'll click Offline Simulation. Now, if I assign a value to word 0, it should be saved in word 1. I'll assign the value 10 to it. You can see that it was saved in word 1. I'll enter the base value in word 1. You can see it was saved in word 2. And I'll enter the value z in word 2. And it gets saved in word 3. In this way, you can assign values to the addresses you've specified. So, in this video, we became fully familiar with numeric input, output variables, and numeric variable displays.